this is page, oh, it doesn't want to move for me, hang on. That is page, somebody said 78, no, it's 55, 55, 55. So this is not on the quiz. Yes, but I have to cut off somewhere for the quiz, and I think, you know, because it's tomorrow, it doesn't make sense to teach it to you today and then have it on the quiz tomorrow, right? That's a little bit too, there's not enough time for review. Okay. So this will be, there will be a quiz on this sometime after we get back. It won't be the first day back because that's also not reasonable. Maybe like Wednesday or Thursday back. Okay, something along those lines. Yes, exactly. But we're not going to spend a lot of time reviewing because we have to get through reactions and stoichiometry, and we have 3 weeks to do it. So we're actually going to cut moles short. You're going to see there's sections in here we're not going to get to. If you're interested, I do have videos on those sections because I taught them to my enriched class. So if you're like, I'm going to university and I would like to know how to find an empirical formula, for example, then you can, you know, do that. If you're like, I'm just taking chemistry 11 for the credit, then you can just be like grade 11 credit and I don't want to go on with it, then you can just ignore it. Does that make sense? And if you're like, if you decide, you know, over spring break or semester break or whatever, if you want to do some of that stuff and you have questions, you can always email me or you can drop by like during flex time anytime and ask me about it. Okay, so, huh? Empirical formulas, it's like 5.4 or something along those lines, okay? Anywho, so we have the solute, we have the solvent, and solutions in which water is the solvent, so that's our third paragraph. Those are aqueous solutions, and remember we signify that with a little bracket, AQ. Is good? Is this all ringing bells? Okay. What we're going to be focusing on today is the concentration. What does it mean, the word concentration? Yeah, how much solute is in the solvent, okay? How much solute is dissolved in a solvent? So we want an amount in the numerator and an amount in the denominator. So we could have grams of solute per liter of solution. We could have milligrams of solute per liter of solution. You'll notice I'm saying solution, not solvent. Yes? What is a solution? It is the solute plus the solvent. Because it is actually quite difficult to figure out, it's much more reasonable to mix the two together to a final volume of 1 liter than to try to figure out what the total volume is with the solid plus the liquid. You know what I mean? Like it's like, it becomes complicated. So it's much easier to just put the solid in. And actually there's a picture of it here. So we put the solid into the flask. Then we add some water. Okay, does that make sense? And then we swirl it around and we say we want 1 liter of solution. So we fill it up to 1 liter. That's 1 liter of solution, which is the solute plus the solvent. Now, the one that we most often use, to be honest with you, is moles per liter. This is the most common. So that is the moles of the solute per liters of solution, which is the solute plus the solvent. So if you want to make 1 liter, you are not going to use 1 liter of water, because if you add the solute to that, it will give you more than 1 liter, because the solid takes up some space as well. Does that make sense? Okay. So if you were actually to add 1 liter of water, you would end up with a volume of more than 1 liter. Does that make sense? Because we would have the solid plus the solute is more than 1 liter. So that's a no. This is yes. Sometime this week, I'm going to have you make a solution, maybe Friday. Okay? That seems like a nice thing to do. 30 minutes. So just perfect amount of time to do something simple like this, right? So the quantity of solute can be expressed in moles rather than as a mass. So you need to be able to convert between moles and mass. What do we use to convert between moles and mass? The molar mass. And what units is the molar mass in? Grams per mole. And where do we find that? On the periodic table. Because in a lab, can you go and count out the number of moles? Right? Like if I gave you some, you know, iron filings or something, just little pieces of iron, you couldn't be like, oh, here's a mole. You would have to figure out a mole somehow. And do you remember how Tyler figured out how many moles he had? What did he do? He weighed them. Yes? So if you want 1 mole of carbon, get your periodic table out. If you want 1 mole of carbon, how much would you weigh out? 12 grams. If you wanted 2 moles of carbon, how much would you weigh out? 24 grams. Okay, so you just have to be able to do that conversion to grams to know how much to weigh out. Now we have a word, and this word causes confusion, so I want you to listen very closely to this part. Moles per liter can be written as either the full thing, moles per liter, or abbreviated MOL over liter. But just like some other units, like a Newton, for example, is a kilogram meter squared per second. Okay, that's what a Newton is, but it's hiding kilograms and meters and seconds. Yes, they're hidden in there, so because who wants to write that out all the time when you could just write N? Yes? Just like that, we often don't want to bother writing out moles per liter, so we just write capital M. Capital M means, it means mega, but it also means moles per liter. So the 2 units are in that one capital M. Okay? These two are the same. Now, the other thing that's a little strange is the way we pronounce this. We pronounce capital M molar, like your tooth. So if I say 1 molar, I mean 1 mole per liter. If I say 0.5 molar, I mean 0.5 moles of solute per liter of solution. Is good? Okay, I will keep reminding you of this because I know it's weird language and it's just, you know, it takes some time to get used to it. Now, one way to represent concentration, we want to represent molar concentration. And by molar concentration, what does molar mean? Molar means moles per liter. So that means the concentration in moles per liter, as opposed to grams per liter or milligrams per milliliter or whatever. The molar concentration can be represented by the letter C. Okay, if it's typed for you, it'll be italicized. Obviously, you do not have to italicize anything. Now, if I want to say the molar concentration of a particular substance, I use that substance as a subscript. So if I want to say the concentration of NaCl in moles per liter, I can write C, and then as a subscript, I can write NaCl. That means the concentration of NaCl, specifically in moles per liter, not milligrams per, you know, kiloliter or whatever. Now, to be honest with you, when we are typing, it's really a pain to try and do the formula as a subscript. Yes, but that it's like it takes some time, yes? And in fact, this notation is not used as often as our next notation. This one is the more common notation. Okay, so this is the better one, better. And this is the one that people forget because it's new and it's different. And why would it mean what it means, right? If I put square brackets around it, square brackets around means concentration, molar concentration of. So this also means concentration of NaCl in moles per liter. So this is way easier to type, and quite frankly, it's probably easier to write as well, especially because, I wonder, do I have any examples? No, but if you wanted to write, like, let's say you wanted to say concentration, molar concentration of sulfuric acid, you could do it one of two ways. What's the first way you could write it? C, yes? C, and then what? H2SO4. And do you see why it's not really nice typing this because you've got subscripts within subscripts? Yeah, there's like little numbers that need to go lower than the already subscripted H2SO4. It's really ugly. I know how to do it, it's a pain. Or, secondly, what's the other way we could do it? We could put square brackets H2SO4, like that. And I would say this is preferred. What do I mean by molar concentration? Remind me. Molar concentration, that is capital M. And what's the other way of writing that if I wanted to? Moles over liters. Am I repeating myself too much? No, I didn't think so, because I'm gonna repeat myself over and over and over again until it becomes more natural. Okay? Now, there are two ways of writing the formula for finding molarity. It's actually pretty straightforward because molarity, capital M. Have I used the word molarity yet? No. Okay, that's another word that we need to define. Molar concentration is also known as molarity. So molar concentration, AKA molarity. So much vocab here, right? So the molarity is the concentration in moles per liter, just like the molar concentration. So there's two ways of finding this molarity. Molarity is equal to the moles over the liters. Yes? So molarity is equal to the moles over the liters. So that's one way of writing the formula, is to say the concentration of substance X, the molar concentration, the molarity of substance X is equal to the moles of X per liter of solution. I'm going to get rid of that because it made it look really ugly. Okay? The other way to write the formula, what's the other way of writing bracket X bracket? What does bracket X mean? What does X in brackets mean? Concentration. It means molar concentration of what substance X, whatever that should be. The other way to write it is the concentration of substance X is equal to, now do you remember what the letter N stands for? N stands for the number of moles. This is back from unit 1. Okay. And V stands for volume. And if you like using that formula, that's fine, okay? For myself, I actually prefer this other one because it's a little more like just obvious what I'm doing. I'm taking my moles and I'm dividing by my liters. I don't have to remember that N is moles, right? Because moles is moles. That's easy. Yeah? So actually calculating a molarity, calculating a molar concentration, calculating the moles per liter is really simple because all you take is one number and divide by the other number. It's just a matter of knowing when to use the square brackets and what all the words mean and all of that kind of stuff. The math itself is simple, simple, simple. Okay, so let's take this question here. Okay. And in fact, I'm going to rewrite it over here. So 0.25 moles of LiCO3 are dissolved in enough water to make 460 milliliters of solution. Find square bracket Li2CO3. Okay, now hopefully you can kind of read my writing there. If not, the question is on your paper, yes? So if we have 0.25 moles of that should say Li2CO3, I have dissolved it in enough water, because remember we have to add the water to up to a particular volume, to make 460 milliliters of solution. What do we mean when we say square brackets LiCO3? What does that mean? Concentration in what unit? Moles per liter. What's another way of saying concentration in moles per liter? Another way of saying that is big M. Another way of saying that is the molarity. Another way of saying it is the molar concentration. And another way of writing it would be concentration of Li2CO3. So all of that's the complicated part. So what we're going to do is we are going to write, I want to find, what's my unknown here? My unknown is the concentration of Li2CO3. So that's how I start, okay? And then what I do is I say is equal to the moles over the liters. And then I say, oh, what goes in the moles place? 0.25 moles. And can you do that conversion from milliliters to liters? Yes, it is. You have to move your decimal place 3 places. You do not need to show the conversion if you can do it in your head. Okay? So you're going to move the decimal 3 places to convert from milliliters to liters. So if we have 460.0, we're going to take our decimal and move it 1, 2, 3 places. So now we have 0.460. Do I need another 0? Yes, because that has 4 sig figs. Okay, so that is milliliters equals that many liters. If you want to use conversion factors to do that conversion, you are quite welcome to, no problem, but you don't have to. You can just move your decimal place and write liters. So we have 0.4600 liters, and we calculate that 0.25 divided by 0.46 equals 0.54347. Wow, that's way too many digits. How many digits should I have in my answer? Just 2. So I'm going to round here. I look to the right and I see, oh, that's a 3. So I need that to become 0.54. And my units, the only thing that's left is moles and liters. moles per liter. Or, how else could you write it? 0.54 molar. So, is the math easy? Are the words becoming easier? Little bit? Little bit. Okay. I'll take a little bit for now. All right. Next question. A sample of 203.082 grams of potassium hydroxide is dissolved in enough water to produce 2.00 liters of solution. Find tell your partner, what does that mean, the thing I've highlighted? You can work on the stuff we did yesterday. Yeah? Well, if you need to put your head down and rest. I know, I understand. I wouldn't either. So that means concentration of potassium hydroxide in moles per liter. What's another way we could write that? C subscript KOH, or molarity of KOH, or molar concentration of KOH. Like I said, this is the only part of the problem that's difficult, because if we want to find molar concentration of KOH, do you need to write this part down? This part here? Yes. You must write what you are solving for. I mean, you could write the C with the KOH as well, okay? But you have to write something. You wouldn't do that, no. Oh yeah, no, it just means the how much KOH. So we have how much KOH. What units go on the top? Well, we want to have moles per liter, so I'm just going to put that in here for now. There's two ways of doing this problem. Yes? Do we have the moles? No, we do not. What do we have? We have grams which can be easily converted into moles. So you could do that step first and then divide by liters. I'm going to show you that next. But right now what I'm going to do is I'm going to say, I don't know my moles per liter, but I do know that I have 203.082 grams per 2.00 liters. And I don't want grams, I would like to have moles. So I need to cancel my grams and find my moles. Where do I find my number for this? On the periodic table. K is it 39.1? K is 39.1, oxygen is 16, and hydrogen is 1. So we have 1, 16, 56.1. 56.1 grams per 1 mole. Plug that into your calculator. 203.082 divided by 2 divided by 56.1, and we get 1.18. And the only units left, you can see the grams cancel with the grams. What's left over? Moles and liters. So we have moles per liter, or 1.0, I've got my digits mixed up. Sorry, that was supposed to be 1.81, not 1.18. I'm looking at my calculator. I'm like, that's not what I wrote. 1.81, what else could we write there instead? M, what does that mean? How do you pronounce that? Molar. Okay. Let's say that's too complicated. Let's say you don't like that. That did not make sense. If it makes sense, great. You can just stop listening for a moment. You can start on the exercises. Alternately, you can say, I need to find the concentration of KOH, and I know that I need to find my moles per liter, but I don't actually have moles. So I need to first of all find my moles of KOH so that I can put it up here. Yeah? So I can do it in 2 steps basically. So I would say I am starting with, just like we did the other day, 203.082 grams of KOH times 1 mole per 56.1 grams. That's the molar mass. Okay. And I calculate that 203.082 divided by 56.1 gives me 3.62 moles. So from here, we just say I have 3.62 moles divided by 2.00 liters, right? I take my moles and I plug it in up here. And we get 1.81 molar. So whether you choose to do it in 1 step or whether you choose to do it in 2 steps, totally up to you. Either way is good. You guys want to try a few of the exercises? Excellent. Did anyone want a printout of what I wrote here? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll make a class set. Okay, cool. because you need more sleep, I can almost guarantee that's at least a chunk of it. Brains do not. Yeah. Uh-huh. Yep. Uh-huh. Yeah. It's just converting between the substances. Sometimes you forget to do that. At least if I'm understanding correctly. On that stuff, like on the stuff 5.1, 5.2? If you'd rather do that first, if you've done all the ones in there already, you have, yes? Is that okay? So you want more practice on 5.1, 5.2, is that what you're saying? Oh, here we go. Because I need a book. We are going to be doing, we're using molarity as a conversion factor, page 59. So that's pretty straightforward. And then we might go on to molarity grams and particles. Yeah, we're just adding particles onto the picture. Yeah. Well, I don't think we're going to get through all of it today, but in theory, pages 59 to 63, or 64 rather. I think so. Today, I haven't. I'm going to print this because I don't know what I'm thinking yet. That sounds like a plan. All right, I will be right back with that printed out. Maybe. Print. There we go. That's better. And I'll turn on the lights so you don't all fall asleep. Yeah. The 1 is exact, the 63 is not. 63.0, because if I was to give you a different periodic table, there would be a different number of decimal places, right? Like, so if I had my AP periodic table, all their molar masses go to 2 decimal places, and even those are rounded off. Like, if you look at them up here, argon is 39.948. We have magnesium is 24.3050, right? So all of those are approximations. Yeah. Is there anyone who did not get one of these who wanted one? I did not make it to this row. Okay. I knew there must have been somewhere because I got a lot in my nose. I know, right? I don't know. No, this is fine. That was fine. Yeah. Not probably in about 10 minutes, I'm going to use molarity as a conversion factor. It will be recorded, and it's whatever the next section is. Yeah, and I'll put it on Teams as well. I'm sorry. Yeah. Okay, so we are going to page 59. (5.3b). So guess what? Moles over liters, you have something over something else. That can be a conversion factor. So maybe in a problem, instead of being asked to find the molarity, perhaps you will be given the molarity. Yes? And you will be asked to find how many liters contain this many moles. Or you might be asked to say, if I give you this many liters, how many moles are in there? Okay? So we're always going to rewrite capital M when it's given in the question. What is that? How would we pronounce that? Molar. We're always going to rewrite the molar as moles per liter because then it works as a conversion factor. The other thing you are always going to do, so there's two always things, always rewrite molarity as moles per liter, and you're always going to rewrite your milliliters as liters. And in order to do that, you need to move your decimal 3 places to the left. Divide by 1,000. Move your decimal 3 places to the left. Now on your molarity, you know the sheet at the beginning where it's got all the different mole conversions? Sure. Like maybe this one? Yes? Okay, so we have been bopping around all through here, right? This is what we've done so far, all the yellow stuff. That's what your quiz is on tomorrow, all the yellow stuff. Now we're going to add in, this is not on the quiz, volume of a solution going to moles and back. Okay? And from there, if you can go from volume of a solution to moles, you can go to grams, you can go to particles, okay? But for today, the only conversion we're doing is between moles and volume. So we're going to start by going from liters to moles. How many moles of NaCl, that is our unknown, are present in 600 milliliters of 1.55 molar NaCl. Now remember, you are going to rewrite this as 1.55 what? Moles over liters. And what that's going to be is that is your conversion factor. So the only tricky bit here, again, is the fact that that capital M is hiding moles and liters, right? You don't see them in the capital M, right? So you might be like, I don't know what to do. So I'm going to remind you all the time, capital N means moles per liter. And you're always going to rewrite capital M as moles per liter. Then you'll see the moles and you'll see the liters and you'll be able to cancel them. And the other thing, because we're working in moles per liter, you want your volume to be in liters. So we're going to take 600.0 milliliters and we're going to move our decimal place 1, 2, 3 places over, which gives us 0.6000 liters. So that means that the liters is our initial quantity. That's what we're starting with, okay? And that's hard for a lot of people. They always want to seem to start with the molarity, but your initial quantity here is the liters. So we want to find moles of NaCl. That's what we don't know. And we're going to start with our initial quantity, and we're going to multiply by the molarity, which is our conversion factor. Ravina, could you get the door for us, please? Or, yeah, thanks, Tiana. So if you look at this, what's going to happen to your units here? What units do we have? We have liters on the top. We need it to cancel with liters on the bottom. Yes. And what are we left with after those cancel out? Moles. And that's what we wanted, right? So that's a good thing. 3 sig figs, do the math. That part's easy. Yes, plug it into the calculator. Okay. Okay, example number 2. How many moles of KBr, so that is our unknown, would you need to make 250 milliliters of 0.150 molar KBr? What is our initial quantity in this question? Tell your partner, what is the initial quantity? What are we starting with? We have 3 choices. Is our initial quantity the moles? Can't be the moles because that's the unknown. Yes? Is our initial quantity the molarity? Remember, molarity we are going to rewrite as moles per liter, so that is going to be our conversion factor. So by process of elimination, who is the initial quantity? What are we starting with? There's only one thing left. Liters. That is our initial quantity. So we're going to rewrite 0.150. Hi, thank you. Modesta. So we are going to rewrite 0.150 molar as 0.150 moles per liter. That's now our conversion factor. We're going to rewrite our milliliters as liters. 250, that's 2 sig figs. So we're going to keep 2 sig figs. That is our initial quantity. So our unknown how many moles of sucrose can we get if we have 0.25 milliliters? Oh, here's a fun one. Do you guys know what the word of means in math language? Of means times. Per means divided by. And the reason I'm bringing this up right now is because in questions like this, look what we've got. I've got an of here. I have 250 milliliters of times, so 250 milliliters times 0.150 moles per liter. The only thing I need to do is make sure my milliliters have changed into liters, and then if I make of times, then it works, right? That many liters of 0.150 moles per liter and if you look, did it work? Well, yes, my units cancel, the liters cancel out, and I am left with moles. So my mathematical translation of to times actually works very nicely for questions like that. Okay? So just for the next few minutes, I'd like you to try question number 1 and maybe 2 if you have time. Okay? Question number 1 though, for sure. And your homework is just to study for your quiz. You can leave this stuff alone.